Welcome to Ezel Engineering YouTube channel. Today I will show you complete factory or warehouse structural design on CSI ETABS software. Project detail. Let's tell you something more about this project. Material used, how to use steel roof truss and concrete frame for both beam and column. First span length, it's up to 30 meter, and the total height of the factory from the normal ground level is 11 meter. Let's open this project and tell you some project details. The depth from ground to base is up to 2.5 meter, and the height between the ground floor to the intermediate beam is 4.7, and from the intermediate beam to the top tie beam, that is 4.3 meter, and the height of the truss is 2 meter. So using all this data, we are going to model our project by defining both material and section property. Watch this video up to the end to master structural designs of industrial building. Now it's time for subscribe my channel to get daily updates tutorials free. Thank you so much. Let's dive into today's tutorial part. Go to File, New Model. Make it save this file that we have modeled before. A new model initialization box is coming like this. From this, we have three choices. From these three choices, it's better to use the third choice, that is use built-in setting with. So you can correct all data by the user. So from this, you can use any local building code of standard here, but in our case, it's better to use European norm of standard. And from this display units, let's use metric SI unit. And origins for default material, let's use Europe. Steel section database, let's use Euro. Steel design code, let's use Euro code. And concrete design code, let's use also Euro code. So make it okay. The grid spacing template is coming like this. So let's open our model and let's insert all the data using the model file that I show on the screen. So let's open it. From this, make it a plan. From the plan, make it ground. So from this, let's use the grid index spacing is 1, 2, 3, 4, 5, 6, 7 with 8 meter spacing, and the grid in Y direction is 1, 2, 3, 4, 5 with 7.5 meter span each. So I'll have to use this data for modeling purpose. So number of line in X direction, let's use 8, and number of grid line in Y direction, let's use 5, and the spacing of grid in X direction, that's 8 meter, and the spacing of grid in Y direction, it's better to use 7.5 meter. Let's go to the grid levels. From the grid level, X grid ID, it's start from A, that is from the left to right, and that of Y grid ID starting from 1, that is from top to bottom. Check our grid, that is like this. So you cannot edit anything here. This is because all the spacing is symmetrical, so make it okay. From this, let's go to the story data. From the story data, let's check the model file that we are going to model first. So right click on it, add or modify grid, modify story data. From this, we have 4 story data, that's ground, intermediate, the tie beam and truss tops. So the dimension or the height is like this, and the total elevation of or the total height of this project is 11 meter, that I have told to you before. So using all this data, let's proceed to model our project. So we have used a total number of story, that is 4. A typical story height, let's leave it, and the bottom story height, that is 2.5, that is the foundation depth. So go to the custom story data and edit all this data. So the first story data is that ground floor or the ground, and after the ground we have intermediate. Yes, intermediate. We have intermediate. After this, the third story is that a top tie beam, that is a tie beam. Yes, tie beam. After the tie beam, I will have a truss top. Yes, truss top. You can give any name here. So the dimension or the height between the base and the ground is 2.5, that is a depth of foundation, and between the ground to the intermediate, it's 4.7 meter, and between the intermediate to top tie beam that is 4.3 meter, and the height of that truss, that is from the tie beam to the top of that truss, it's 2 meter. So make it minus 2.5 meter. So the total elevations of our project is 11 meter. So after this, we are going to define all the story datas. So make it okay. After that, click on grid only. Make it okay. So all the grid spacing is defined like this. Save your model first. Go to File, Save As. Yes. Let's use this name. After that, make it a tutorial. So save it. Let's go to define all the section and material properties. So to do this, go to the define menu, material property. From this, add new material here. So for C30 concrete grade, it's better to use all these property. That is the region, it's Europe, it's good, and material type. It's concrete and standard, that is European norm of standard, and grade that is C30 that we are going to use for column, footing, and the beam. So make it okay. After this, it's better to use all the default material as it is. Make it okay. So the concrete properties defined like this, but it's better to go to define the reinforcement detail, that is S500. So to do this, make it add new property, and the region is Europe. So the only difference is that it's a material type. Make it rebar. Define all the property using the user defaults. So make it okay. So rebar, make it S500. So you think this all the data are good, but the only difference is that modulus of elasticity, it's better to use 210 1 to 3. Yes, this megapascal for steel reinforcement. So the other difference is that go to modify here. So 4 is 500. So make it 500. That is the grade. So the minimum yield strength is use 500 divided by factor of safety, that is 1.15. So cancel this digits, and it's equal to that of the expected yield strength. So copy it here. After that, it's better to use minimum tensile strength, that is 500, the grade itself. So copy this data. Click on here, paste. Okay. So we are going to define all the concrete grades as C30, yes, and reinforcement grade, that is S500. And let's proceed to define all the property of a steel section. So for steel section, it's better to use the default settings, that is S355 grade. So go to modify. So from this, let's go to define some property for that of S550 divided by factor of safety, as I told it before. So you can copy all this data to this. After that, you can use 355. Yes, it's equal to the minimum tensile strength, that is 355. Make it okay. So all the material for the steel section, the reinforcement rebar in concrete grade is defined like this. Make it okay. Let's proceed to define the section properties. Go to define menu, section property, frame section. From this, let's go to add a new property. From this, make it concrete. From this, let's use column 400 millimeter by 400 millimeter. So the material type that we have to use is C30, and the section shape is concrete rectangular. So depth and width, it's 400 by 400. Go to the stiffness modifiers here. So to know more about stiffness modifier, if you're interested, it's better to go to all my tutorials and check it again. So make it okay. And the rebar property, for rebar purpose, I have to change all these data for S500, and that is make sure that I have to select for a column. After that, make it okay. So the column is defined like this. Let's proceed to define the beam section. So add new property, make it concrete. So a beam 500 by 300 millimeter. So the material property, it is C30, and the depth is 500, the width is 300. So go to modify or show reverse, yes. So I have to change all these properties. That is the property that we have defined for reinforcements. So make sure that change it as the beam. After that, you can calculate the top and the bottom spacings for this. Also go back and check all my tutorials. So make it okay. Okay, let's go to define steel section properties for the truss member system. So go to add new property. From this, go to the steel section is here. From this, use a box or a tube section, top and bottom. That is for top and bottom of the truss. It's better to use 80 millimeter by 80 millimeter times 3.5 mm section. So material property, let's change it as 355 that we are going to define before. So the section shape, it's steel tube, that is good. So the total depth, it's 80 millimeter, 80 millimeter. So the flange and the wave thickness is 3.5 millimeter, 3.5 millimeter. So make it okay. After that, let's go to define the diagonal in the verticals. From this, let's use this property. So add a copy of, so vertical and horizontal members, that is 60 by 60 by 3.5 millimeter. So all the properties are like this, but the only difference is that 660 and make it 60. So let's check this property, go to modify, cancel this 0. So that is good, make it okay. After that, let's go to define the purlins. So add a copy of this property. So from this property, make it purlin, yes, make it purlin. That is 30 by 30 by 2.5 millimeter. That is good. Make it 30. Make it 30. After that, make it 2 millimeter. For all this data, you can check the local or the market standards. So make it okay. Let's proceed to define the ASCE sheet properties. So from this, go to define menu, section property, go to the slab section. From this, you can change this property. So modify this property. So a roof ASCE sheet, make it a roof ASCE sheet. You can use for ASCE sheet up to 0.3 up to 0.5 millimeter thickness. For the slab material, let's change it as S350. Very important point from this, the modeling type, make it membrane here. So the type, it's a slab actually, and the thickness, you can change the thickness, that is 0.4 millimeter. So you can define your ASCE sheets for your roof like this, make it okay. Okay, let's go to draw all the columns here. Click draw column. So select the column section definition, that is column 400 by 400. So you can draw like this, all your columns like this, yes. For the intermediate one, like this. So let's proceed to draw our beams. Go to click draw our beams here. So change the property as beam 500 by 300. So you can draw like this our beams also, yes. Like this. So let's replicate this to the intermediate and the top one. So select all, replicate by story, click on the intermediate and top tie beams here, make it okay. After that, go to the intermediate ones here. So cancel all these beams. This is because our project is industrial building, so the beams around this has a disturbance manner, so cancel this. So make it ready. Beam and column is drawn or model like this. Let's proceed to draw the truss members. So to do this, go to elevation menu, select one elevation, that is elevation A. After that, go to draw beam here. So select the property that is top and bottom. So using this property, click on here, click here, click here, turn back to this point. After that, let's go to draw all the vertical and horizontals. So to do this, click on here, go to the edit menu, edit frame, divide frame. So the total length is up to for this truss is 30 meters. So the half is 50 meters. So it's better to divide this frame to 40 joint objects. So make it okay. After that, go to here. So click on joint level. So all the joint level is shown like this. After that, right click here. So go to the snap option. Check this box that is to know the midpoint, and also check this point to get the perpendicular projections here. Make it okay. After this, go to draw beam also. Change the property as horizontal and vertical. From this, simply click on here, click here, click. You can draw all the verticals like this. And for the diagonal one, it's so simple. You can draw it in this way. After drawing all this horizontal and vertical, I will show you how to draw the purlin and egg gasket within 1 second. Take care of do not pass the intersection point and the angle. Yes. Let's draw also the diagonal one around this position. This is all about the truss member modeling. So let's replicate all this to the other axis. So let's make it in 3D. After that, let's replicate to this all these axes. So to do this, go to select menu. So it's better to select by property here. So frame property. So let's replicate all the top and bottom plus the vertical and horizontal. So make it select this, close. After that, go to replicate. So from this, we are going to replicate to the x-axis. So make dx as 8 meters here. So the number is 1, 2, 3, 4, 5, 6, 7. So make it 7. After that, apply it. Okay. After drawing all the truss member like this, let's proceed to draw all the gasket and the purlins. So to do this, first it's better to select the section property, that is make it purlin. Yes. After that, let's go to the elevation, that is elevation A. After this, let's select all these joints one by one. After selecting all these joint one by one, I will show you a trick to draw the purlin within 1 second. So pay attention here. Select first all the joints that the purlin will pass from this extrude joint to frame. After that, let's go to select as dx, that is 8 meter, but cancel on the dy, and the total number is 6. This is, I will show it in 3D. Yes, the total number, that is 1 2 3 4 5 6 7. So make it 7. Yeah, after that apply. Okay, all the purlin is drawn like this. Let's check the property of material that used for the purlin purpose. Right click here. So the section properties purlin, that is good. So for the ECA sheet modeling purpose, let's first select the material, that is roof ECA sheet 0.4 millimeter thickness. So after this, let's go to elevation. Yes, make it elevation A. After that, it's better to select all these lines one by one. Yes, all these lines one by one. Be careful for selecting all these lines. After selecting all these lines, I will show a similar trick. So simple. So be attention here. After that, let's go to edit menu, extrude frame to shell. Yes, from this you can use dx, that is within 8 meter. Cancel on dy. Yes, we are not interested to draw along dy, so the total number, that is 7. After this, make it okay. So let's check it. The shell is drawn like this. So let's go to check the property of shell, that is a roof ECA sheet with 0.4 millimeter thickness. That is good. Let's go to the extrude view to check the thickness. So let's cancel all the joint points here. Yes, you can draw like this. These were the most important part regarding to material definition, section property definition, and all about modeling. In the next consecutive tutorial parts, we will show you how to define, assign, and combine loads, how to analyze, design, and detailing all the structural elements in detail. See you there. Thank you for watching. Have a nice time. Goodbye.